In this video, I'll be dealing just with 3 problems from exercise 4, 6.2, namely problems 2, 7, and 8. Exercise 4 really cranks it up a notch. In exercise 3, every single variable was in fact defined for us. But if you read through the directions in exercise 4, you'll notice that A and B, just as they were in exercise 3, A and B are defined as true, Y and Z are defined as false, but P and Q have unknown truth values. So anytime we see a P or a Q for that matter, we have to leave it as a question mark. The only thing that we can know, given that it stands in place of a proposition, is that it's either true or false. We just don't know which. We don't know which is the case. So let's just jump into solving problems here. Again, really the only way to learn logic is in fact to solve problems. So let's have at it. Problem number 2 is Q or Z. So I've gone ahead and copied down the problem just as it appears in the text. In my next step, just the same as it was in exercise 3, is to plug in the truth values that I know. Q, however, is a question mark. It's an unknown truth value. So I'll just indicate as much by writing a question mark. I'll copy down the operator, or Z now we know to be false. Z we know to be false as defined by the directions for us. So we want to know, if possible, the overall value of the wedge. Can we know the value here? Well, again, we know that Q, given that it stands for a proposition, is either true or false. So we can really branch off the possibilities here. Let's suppose, first of all, this will be possibility number 1. So I'll just create a couple of different branches here. Let's suppose that Q is true. That would give us T or F. And then the other possibility, branch number 2, would be that Q is false. Again, it's got to either be true or false. So in this case, possibility number 2, branch number 2 if you like, we'd end up with F or F. So what's the value of T or F? Well, one or more of the disjuncts is true, so the whole thing would be true. Whereas in this case, this is our special case, F or F is the only way for a wedge statement to be false. So in this case, the overall value of the statement is contingent upon the value of Q. Since we don't know Q, we can't know the overall value of the statement. It could turn out to be true if Q is true, or it could be false if Q is false. So this one, the overall answer, which I've now just circled, is a question mark. It is unknown. Let's now go on to problem number 7. Problem number 7, we've got A horseshoe P. So again, let me plug in the values that I know. A is defined as true, whereas P, once again, is a question mark. So we get down to T horseshoe question mark. Can we know anything here? Can we know anything here? Well, again, if it's not perfectly obvious to you, let's explore the possibilities. In each case, we're going to have T horseshoe something, so I'll go ahead and copy down as much, T horseshoe something. P, again, given that it stands in place of a proposition, could either be true, we'll say that's possibility number 1, branch number 1, or P could be false. So what if it were true? What if P were true? What's the value of T horseshoe T? Well, T horseshoe T turns out to be true, whereas T horseshoe F, that's our special case, turns out to be false. So just as we saw in problem number 2, the overall value of the statement is contingent upon the value of P. It could turn out to be true, it could turn out to be false. So this too turns out to be one big question mark. Let's skip ahead now to problem number 8. Problem number 8, we're given P triple bar not P. P triple bar not P. So let's plug in the values that we know. P is a question mark. Triple bar, tilde, just copy those down, bring them down one line. The P still, well, it remains a question mark. So we get down to question mark, triple bar, not question mark. And here you might think that you're completely stuck. Maybe we've arrived here at an impasse. And so, since we can't seem to figure much of anything out, the overall value must be a question mark, right? Well, again, let's take a look at what we've got here. We've got P triple bar, not P. And once again, we know that P stands in the place of a proposition, so P must either be true or false. So let's explore the possibilities here. And once again, we'll branch things off. What if P were true? If P were true, it's got to be either true or false. So what if it were true? If it were true, we get T triple bar not T. The other possibility, of course, is for P to be false. If P were false, we'd get F triple bar not F. So let's solve both of these and see if the overall value is truly contingent on the value of P, or conversely, are we able to figure it out? Let's first take care of the tilde, as the triple bar is the main operator. Not true is false. So we get down to t triple bar false. They're different, so the whole thing turns out to be false. That's possibility number one if p were true. What about possibility number two, where p is defined as false? Here again, the main operator is the triple bar, so let's take care of the tilde first. Not false is true. So we get down to f triple bar t. Here again, we've got a mixed bag, and so the overall value here would be false. Notice this time, unlike 2 and 7, even though we started with 2 question marks, we can in fact figure out the overall value. No matter what the value of p is, given that it has to be either true or false, we know that the overall value must be false.